Hi guys, welcome to my channel. In this video, let me explain the SLR1 parser, which stands for Simple LR Parser. It is the one of the most important parsing techniques used in the compiler design. During this presentation, we will learn how an SLR parser works, how it constructs the parsing tables, and how it parses an input string step by step. Let's go in detail with the slides and let's understand. Before we begin, let's look at our learning objectives. By the end of this presentation, we will be able to understand what an SLR parser is, learn why it is used in the compiler design, understand how an LR0 items are constructed, learn how a follow sets are used, build an action and go to tables, and finally see how an parser analyzes an input string using the shift and reduce operation. Let's go with the next slide. Introduction to SLR1 parser. What is an SLR1 parser? An SLR1 parser is a bottom-up parsing techniques used in a compiler design to analyze whether an given input string follows the grammar of the programming language. It belongs to the LR family of the parser, where S is a symbol, L scans the input from left to right, R constructs the rightmost derivation in the reverse. One uses the one look ahead symbol while making the parsing decisions. This parser mainly performs the two operations, that is shift and reduce, until the entire input string is accepted or rejected. I hope you guys understood. Let's move to the next slide. Why do we need SLR parser? Some grammars cannot be parsed using LL parsers because they contain the left recursion or more complex. It supports the larger class of grammar, detects the syntax error efficiently, produces the deterministic parsing decision, and parses the efficiently in the linear time. Some of the applications are like it is mainly used in the compiler construction, in the syntax analysis, and the parser generators like Yak. I hope you guys understood. Let us see the next slide. Characteristics of SLR parser. Let's discuss the important characteristics. The first SLR is a bottom-up parser, meaning it starts from the input and reduces it to the start symbol. It is also called a shift reduce parser because it is repeatedly performs the shift and reduce operation. SLR uses the LR0 items to represent the parser's state and follow sets to determine where the reduction should occur. It uses the follow sets. It requires the one look ahead symbol. It not takes more than one. Produces the rightmost derivation in the reverse order. It is efficient and deterministic. Its parsing time is big O of n, where n is the length of the input string. Therefore, it is efficient for parsing the programming languages. I hope you guys understood. Let us go to the next slide. Components of SLR parser. The SLR parser consists of 5 main components. The input buffer stores the input string along with the end marker, that is dollar. The example is you can see ID plus ID into ID dollar. Stack. The stack stores the grammar, symbols, and parser states. Action table. The action table tells the parser whether it should shift, reduce, accept, or report an error. GOTO table. The GOTO table tells the parser which state to move to after a reduction. Finally, the parser driver. The parser driver controls the entire parsing process by consulting the action and GOTO tables. Shift and reduce operations. The parser mainly performs the two operations. The first operation is shift. During the shift operation, the parser reads the next input symbol and pushes it onto the stack. For example, if input begins with ID, the parser shift ID from the input to the stack. The second operation is reduce operation. During the reduction, the parser replaces the symbol on the stack with the left hand side of the grammar rule. For example, if the grammar contains F produces ID, then the parser replaces ID with F. These two operation continues until the parser accepts or rejects the input. Action shift ID. This one is before reduction it was ID. Stack becomes 0 ID. After reduction it becomes the F. I hope you guys understood. Let us move to the next slide. Steps to construct the SLR parser. Constructing an SLR parser involves several steps. Augment the grammar by adding the new start symbol. The next is we construct LR Parser items and compute their closures. After that, then we go to the GOTO transition between the states. After that, we find the canonical collection of the LR0 items which is represented as DFA. Next, we compute the follow sets. Using the DFA and follow set, we construct the action and GOTO tables. And finally, we use these tables to pass the input string. I hope you guys understood. Let's see the example. Let's understand the SLR parsing using this grammar. The grammar is S produces CC, C produces CC, C produces D. We first augment the grammar by introducing the new start symbol, that is S prime. The input string we want to pass is CDD followed by the end marker. Using this grammar, we will construct the LR0 items, DFA parsing table, and finally pass the input. I hope you guys understood. LR0 item sets. An LR0 item represents the progress of the parsing a production. The dot indicates how much of the production has already been recognized. For example, you can see here S prime produces dot S, means the parser expects to read S. After reading S, it becomes a S beginning. After S, the dot will be there, which means the production has been completely recognized. This is how we'll write the LR0 item sets. Each LR0 item sets becomes the states in the parser. I hope you guys understood. Let's move on to the next slide. Canonical Collection DFA. The canonical collection is represented as an DFA. Each node represents the one LR0 item set. Each arrow shows how a parser moves to the another state when it reads a grammar symbol. For example, reading symbol C from the start state I0 takes the parser to the state I3. The DFA forms the basis for constructing the action and go-to table. The DFA shows how a parser moves from one state to another while reading the grammar symbol. I hope you guys understood. Follow sets. This is the grammar you can see. The follow sets contains all the terminals that can appear immediately after the non-terminals. For example, you can see all this. Follow of S contains only dollar because S is the start symbol. The follow of C contains the C, D and dollar. During the parsing table, the construction and reduction actions are placed only under the terminals that belongs to the follow sets of the corresponding non-terminals. This helps to avoid the unnecessary actions. The next slide is action and go-to table. This is the table. The action and go-to table guides the parser. The action table contains the four possible action, that is shift, reduce, accept, error. The go-to table specifies the next state after a reduction. For example, if the parser is in the state 0 and reads C, the action table instructs it to shift to state 3. Similarly, if the reduction occurs, the parser consults the go-to table to determine the next state. This is the table you can see. I hope you guys understood. Next, the parsing example. Now let's see how the parser processes the input string. Initially, the stack contains the state 0. The parser shifts C and then shifts D. Once it recognizes the production C produces D, it performs a reduction. Next, it recognizes the C produces C and reduces again. Finally, after recognizing the S produces CC, the parser reduces to the start symbol. When the parser reaches the start symbol and the input is completely consumed, it enters the accept state. This indicates the input is valid according to the grammar. I hope you guys understood. Next, the advantages and limitations. Some of the important advantages of SLR Parser are: it is easy to implement, it is efficient, so it is faster than recursive descent parser, detects the syntax error efficiently, supports the left recursion, it is widely used in the compiler construction, suitable for many programming language grammars. However, it is also has some limitations. It cannot parse every LR1 grammar. Shift reduce conflicts may occur. Reduce conflicts may occur. Less powerful than LA, LR and canonical LR parsers. I hope you guys understood. We'll see the summary. To summarize, SLR stands for Simple LR Parser. It is a bottom-up shift-reduce parser that scans the input from left to right and constructs the rightmost derivation in reverse. It uses the LR0 item sets, follow sets, and action and go-to tables to parse the input efficiently. Although it is not as powerful as LALR or canonical LR parser, it provides a good balance between the simplicity and efficiency. making it is an important parsing technique in compiler design. I hope you guys understood. Thank you. If you have any doubts, any questions, please raise your doubts in the comment box so that I can respond. Thank you.